Section 2.5, correlation and causation, scatter plots. So the goals here, be able to plot a scatter plot for bivariate data set. Basically, everything we've seen up to this point has been univariate. One variable, one characteristic you were measuring. So your statistic, your parameter, whatever it was just like one thing that you were measuring. Test scores, for individuals, something like that. Here we're going to see bivariate, two things linked together. Be able to determine if a bivariate data set demonstrates correlation. Sometimes you're going to look at the graph of a scatter plot and you're going to see, whoa, these things look related in some way. As one goes up, the other goes up, and we'll determine if it demonstrates correlation. Last thing here, very important, know that correlation does not imply causation. Even if things look like they are correlated, look like they relate, there may not be a cause and effect relationship behind them. The news media gets this wrong a lot, and there's many examples of when the media claims causation with correlation incorrectly, and they don't look a little deeper and say, oh, well, there's other things that actually cause this to happen. It's not just because they were correlated that there's a cause and effect. So this is a very important thing I want you to take away from this section. So with scatter plots, as I said in previous sections, data sets, they just represented one characteristic. And in this section, we'll see data sets that are bivariate. This means that the data set will have pairs of numbers that are linked together in some way. So we're going to use ordered pair notation to represent the paired data values. So for example, you might see something like time and temp. In a time series graph, you would have the time across the x-axis, the temp up the y-axis, and you got all the little dots in there, and you could see over maybe the hours in a day, days in a year, how the temperature changes for a particular region. Or maybe you're comparing height and weight. A lot of times people will compare different body characteristics and see if there's some correlation between them. So height and weight. And because the data values are ordered pairs, you'll be able to plot them on a graph, just like you would with an XY graph, where you take the XY points and go over on the x-axis to the x, and then go up to the y or down to the y, and plot a point. So it's basically the same idea. That's how you get your scatter plots. So in this example, suppose 10 men had their height and weight measured. The data is below. We're going to draw a scatter plot, and I'm not going to draw it by hand, and I don't want you to draw it by hand. I want you to be able to do this with technology, because technology produces much better looking graphs. And if you're going to do this in another class that you're writing a report or something, you want to spice it up with some pretty pictures, I want you to be able to do that. So you can use other things that you're more interested or more familiar with, I should say, like maybe you like Google Docs, or maybe you have a Mac and you use, I think it's like Numbers or something they use on that one. But there's lots of different spreadsheet things out there that can do this for you, but I'm going to use Excel. And you might be saying, but wait, Marcus, I don't have Excel. How can I get Excel? You all have access to Excel as CCC students. You get it for free. In fact, you get the whole Office 365 suite along with a OneDrive account. So you can actually store things and access it from different computers. And you get it all for free since you're a student here. How? Well, you go over to the website. And on the website, you go to the ITS help desk up here in the top right. Click on that. Scroll down the page until you get here, and then look at this Office 365 right here. Click on that. And then you go through these, short 10 steps. And it does go pretty quick, to be honest, because I did it for mine. But you just register, sign up, and then you can get in there. I will say, when you get in, on the right side, when you first go into the account, you've got your Office 365 open. You'll see on the left side a bunch of icons for like Word, PowerPoint, Excel, etc. But then over on the right side, you'll see a thing that says Install Office, and it'll be a little drop down that you'll have to click on. Do that, because the web-based versions of these programs are not as feature-full as the downloaded version. So even some of the things that I'm going to do right here on this one, it won't be available on the web-based version. So you don't get nearly as many of the features up here. So make sure you do install Office onto your computer. And again, as a student, you get it for free. But at any rate, what we're going to do here is just click on this stuff here. You left click, drag until you highlight everything like that. Then you can go to Insert. And then you got all these different chart types and maps. I don't want a map though. I'm going to go with this one because it looks like a bunch of little dots. And a scatter plot is a bunch of little dots. So there you go. And it didn't really give me exactly what I wanted here. I'm just going to call this, oops, if I click on that, height versus weight. And then I got to click over here to get it to stop from being weird a little bit later. So now you can see you got the heights down here and the weights here, and you could adjust different things. You got all kinds of formatting options. I'll let you play with that on your own and make them pretty, or give more detail. You can put labels down here and all this other good stuff. But this will be good for what we're doing. So I'm just going to capture this real quick and then bring it up. And I don't know why that thing popped up there. So just click in this again, and then we'll see if this thing gets crazy. Oh, what the heck? No, don't tell me more. Tell me less, in fact. Not sure why that's doing that. Okay, that's better. Sometimes Microsoft likes to think too much for you. All right, so come back over here. I just got to shrink this up a little because when it brings it in way bigger than what you need. All right, there we are. And that's about right. So, now you got a nice scatter plot, all the little dots. And if you look, at the 67, you can see that it lines up more than likely with that 185 value. So 67 inches lines up with 185 pounds. So there seemed to be a relationship between the height and the weight. Well, to look at that, if we just draw like a line through here and try and get close to all the data values as close as possible, it does look like there's some sort of relationship here. As the height increases, weight increases, and they would call this a positive relationship. As you go from left to right, if one value gets bigger, as the other value gets bigger, they call that a positive relationship, a positive slope to that line. If you've worked with line equations before, you have a positive slope there from left to right, you're going uphill. So yes. And in general, if there seems to be a relationship between the two sets of data, we say that the data is correlated. It's related. The height does seem to be related to the weight. All right, so for correlation, once you have that scatter plot, you can start to examine it to see if the data is correlated. And in this class, we're just going to focus on determining if there's a relationship first, and if there is one, whether it's positive or negative. So positive, you're going uphill, so to speak, from left to right. Negative, you're going downhill as you go from left to right. And we'll also determine if the relationship is strong or weak. And by this, are all the dots really close to a trend line, or are they kind of spread out a lot? So consider the following examples here. So I'm just going to draw a trend line through there. This one positive again, I'm going up as I move from left to right. And looks like the dots are all relatively close to that line. You got a couple that are kind of far away, but overall most of them are very close to that line. So this will be a strong positive relationship. And then over here, this one, again, if you draw a line through there, and this case, it's going to be negative. As you go left to right, you're going downhill. So it's a negative relationship. The weight in pounds for your vehicle, you're going to see less miles per gallon. Anybody who drives a big old beastly vehicle knows you don't get as much gas mileage as a little tiny car. But at any rate, you got the negative there, and then this would be, oops, not weak. what am I talking about there? All the dots are very close to that line. This would be strong. So then this one, looking at this, it's like, even if we draw, and sometimes it's hard to tell, but if you draw kind of a little oval or, sometimes try and capture all the points, sometimes it'll show a little better what the trend is. And I left out this outlier over here on the bottom right, and, even kind of left out that one, even though it could go around it. But in general, it does look like there is a positive relationship here. You're trending up as you move from left to right for most of the points. And it would be weak, though, because you're not really get too close to the line for most of the points. They're pretty spread out. And then this next one, if you draw something around it, it's like a box. It's just like a little shotgun blast or something. So this thing is not correlated, no correlation at all. And pretty much if you ever see anything where it's just like flat straight across, it's got to go up or down to be correlated positive or negative, and otherwise it's there's no correlation. Nothing's really changing as you move through one of the values. All right, so what I want you to do then, and that's basically the examples there that you'll need for the homework for the scatter plot and strong, weak, positive, negative. So another way to think about this is just in words, is there some correlation between the two, values? And I want you to think about that. Okay, hopefully you paused and thought about it, read through these. So GPA versus shoe size, is there a correlation? No. I don't think so. I've seen tall people, short people with all kinds of different GPAs. So, big feet, small feet, doesn't matter. Is there a correlation, or if there is, I should say, is it positive, negative? Well, not applicable since there was no correlation. So age of a car versus the value of a car, and we're only considering the first 20 years because once it gets really old, sometimes it becomes a classic, and then you see people pay ridiculous amounts for classic cars. So only in that first 20 years we're going to look at. And I would say yes, there is a correlation here. Because as cars get older, they are worth less. You can sell them for less money. And if there is a correlation, is it positive or negative? Well, since you get less as you get older, you are seeing a negative relationship. As you go to left to right in the age, you're going to see the value go down. All right, so correlation versus causation. One thing to be very cautious of is the idea of attaching cause and effect meaning to data that is correlated. And I'm just going to kind of pause this video. I'm going to let you just look through these on your own, and you can see probably that it makes no sense. So yeah, Nick Cage drowning in a pool. Funny how it matches up, but it's not hopefully cause and effect. Nick Cage would probably be beside himself. Cheese consumption, people become tangled in the bed sheets and die. It's amazing how it follows, but it's not correlated, or not cause and effect. It is correlated, but it's not cause and effect. And then this last one here, divorce rate in Maine per capita consumption of margarine. It's amazing how they line up, but there is no cause and effect there. At least I hope not. It's weird if there was. So the moral of the story, if you're looking at these graphs, correlation does not imply causation. You cannot ever imply that. There's some things in the news, like I saw once, growing up I used to listen to a lot of heavy metal, and there was a little rash there of suicides, and the people just happened to listen to heavy metal, and it was like, oh, heavy metal causes suicide or makes you commit suicide. And it was like, no, there's probably other things going on in that person's life besides the music they listen to. It was a terrible claim by the media. There's been some other ones, but at any rate, correlation does not imply causation, and only through an experiment can someone conclusively claim a cause and effect relationship between these two variables. Something exists. Because in the experiment you can control factors, and you can see, oh yeah, this definitely causes this outcome. So only through an experiment can cause and effect relationships be determined.